also kind of why I speak up. But more importantly than the voice is what gets written on the board, like notes. But like, so I stand like this, right? The mic points at me because it's got mics on both sides of it. So it picks me up, and I have like a deeper kind of cut-through voice as opposed to you guys when you like. It does not pick you up very well. So, but yeah, if you speak loud, it's in there. So if you want to shout out your mom or whatever, you probably could. So in 357, actually the majority of my videos have like no views, I'm pretty sure. I just put them up there so they're accessible if you guys want to, or if you're sick. So, we need to be efficient with our time today because we have a fire drill happening at 10 o'clock. So we will be sacrificing time. Here's what's up, though. I need you guys to hear this. When we go out, because we're not allergic to walking, we will go out, go across the parking lot. Before you go through the cars, head to the left, all the way to the end of the cars, and then go right beside that car on the end. Because if the grass is still wet, we'd rather stay out of the grass. So head across the parking lot, then left out to the end. There's like a red car parked down there. Stand beside that. Okay? So, date your notes, please, for today. What is today? 28. Now, in 357, it starts by asking us to make sense and explain what this would mean. Negative 18 divided by 9. Negative 18 divided by 9. What could we say to make sense of that? Like, a lot of us probably know the answer, but how do we make sense of what's happening?
When you divide fractions, you usually flip it. So you could flip the 9 into a 9, and then multiply the negative 18 by 1, negative 18 on top, and then divide it.
So you're saying a lot of how to do it. I want to make sense of this first, though. So I try to like give a story or something like that. Or think about when we were working with the integer tiles, right? So if I gave you this problem and we had the integer tiles, and they're still there for Math 7, but we're not really going to use them probably, what would this be asking you to do? Can we go again?
Yeah. We would use the giant line and make a giant and then
you're working really hard still. But go ahead, try. I'm curious.
Split it in half. We'll make 2 groups.
Ooh, so we're thinking 2 different ways, actually. There are 2 ways to think about this, and they're both right. I have 18 negatives. One way to think about division is if I break my total into 9 groups. What will each group have? 2 of my negatives. The other thing to think about, or the way to solve this, like Bougainville was saying, if I split my amount into groups of 9, but I don't have any positives, because all I'm working with is negatives. So if we're trying to rationalize this and make sense of it, the one way gets a little hairy, or a little tricky, because if we had 18 divided by 9, I can take 18 positives and make 9 in each group. But I can't take 18 negatives and make 9 positives in the group and then have negative 2 groups. So the thought process gets a little weird. But if we think about negative 18 into 9 groups, each group has negative 2, and that's easy to think about. So both ways are correct. Just one would make sense in a realistic sense. One would not. So check out A, B, and C with your teams. Try to figure out what the solution to those are and how you could explain it.
Yeah, split 45 into
What? Okay. Is anyone able to explain A to me? Are we there yet?
We're thinking.
Oh. Tyler?
Well, because the question asks 45 divided by -3, what we did was we were thinking that 45 divided by 3, that equals 15, because there's a negative sign. The 15 might have to be the same. Yeah, because it will be. Okay, then it will be. We're kind of still talking about that, but we come to a decision that it will be.
Okay, you give me the math. Why? So, like, when we talked about negative 18 divided by 9, I could say I start with 18 negatives, right? So if I do that here, I start with 45 positives, like a lot of them. And then I want to make groups of -3? There's no such thing as negative amounts of groups. And I don't have any negatives in my problem, right? Piper?
You have 45 and then you're splitting into negative groups. You can't split something into negative groups. So you take away the negative sign and just split it into normal groups. But then you have to put signs for getting negative back on because it is negative, and since you have to kind of carry it over.
What's another way we think about a negative? And someone's already said it today. An opposite, right? In this situation, one of the numbers we work with has to take on the opposite characteristics. Can groups take on an opposite? Like, can you have negative groups? No, just like you can't travel a negative distance. Could 45 of, like, whatever take on a negative characteristic or an opposite characteristic? Can we break up negatives? Yeah. So if this doesn't make sense, which it doesn't really, rework it, and instead of making this the opposite, make that the opposite. This is the same as if we do -45 divided by 3, as long as there's still only one negative. Now that makes more sense to get -15.
Okay.
Good work. Now in B, can I split -32 into -8 groups? No, because I can't have negative groups, but can I split it into groups of -8?
Yes.
Yeah. Fraction blocks, they all add up to 1. So if you can make a stack that perfectly lines up, then you've added up to 1. So you can play with the various fractions and mess with the addition. but now they're not. So, I told you guys, head out, go left. Quiet as you head out. Alright, so outside we talked about b equaling 4, because if I make groups of -8, I will make a positive amount of countable groups. Can anybody talk me through C? How you think it through? -54 divided by 6. So we of course have.
Well, I start with the -54, and so I know, okay, there are 54 negatives, and I kind of think in my mind, like
Yeah, if I see these negative, yeah.
Right, if I see 54, and I need 6 groups, then I split them up equally until I have 6 groups that have the exact same amount, and then, the answer would be 9, because you have 9 in each.
So Tyler says the answer is 9.
It's
-9. Like I said, guys, as soon as you think about my answer being negative, write it. As soon as you think it, write it. Because you will forget. I don't guarantee today or tomorrow or next week, but eventually, one of these times, you'll forget, and then I'll be there in your head, like, as soon as you think it, write it. And then you'll have to, like, be frustrated because I told you so. So just avoid that moment, right? Moving on. 3.2.4, so please put like a squiggly across your notes or something. We are moving into a new section. And this one is all about multiplying. We'll say multiplication. We'll be fancier. Of decimals, which really, decimals are still rational numbers. Are we okay? So, you walk into a sporting goods store, and I'm going to skip over some of this stuff because we need to. Okay, so in case you don't know why we call things decimal, it comes from the base of 10, or deca. So because we are a base 10 system, and every decimal place either multiplies or divides by 10, that's why we use decimal. Decimal. So, you go to the sporting goods store, and you see that all sporting goods are 10% off. I see everyone like, yeah, so the sign is, right, so he must be a mathy guy. And you're like, oh my gosh, 1/10 off. Well, that's not that much, it's only a 10th. So, he saw a pair of rollerblade laces. This is who still rides rollerblades? I love rollerblades. Okay, good. There is still hope for America yet. Okay, so, and this is super cheap. So, rollerblade laces are 40 cents. He wants to find out how much he would save. So, we need to work that out. Then we're going to get resource pages, which I had printed, but I don't know where they went to, so I'm just going to print more. What? Sometimes things walk away if I leave them on the printer.
I know, it's not like things in my room walk away, and they're home, they're under my bed or in my closet. It's very annoying.
Or is it because you put them
Alright, so I just want you first, if we just asked you to calculate a 10th off, how would you do it? So talk with your team. If we didn't tell you any strategies, well, and there's not right versus wrong. There are multiple ways to do this. How would you do it? And if yours is different, share all the different ways that we could do it. Actually, ignore this for now. Okay, ignore that. Just talk with your group.
Okay, so
Let's say
is 4010.
So
So
the
10
100.
I divide by 10.
I know. get 0.4.
No, it literally says
What's
lead.
I know. Yeah.
One tenth of the price.
It's just wasted. Why are we on the five?
Print it. Hot off the press. I'm going to trust that instead of giving you a half sheet, I can give you a whole sheet and you will just keep track of it. So please, when we're done with this, either stick it in your toolkit or clip it in your binder, please. Now, after you've discussed those ideas, follow the steps. Now hold on, give me your attention real quick. I will tell you, as we go through CPM this year, things do not always have to make sense before you start it, or even while you're doing it. But by the end of an activity, you will realize why we've done something. So please trust the process, follow the steps, and work through A through G. Now, if you already think you have an answer, we're going to verify it.
What I'm trying to say is, I got points for price.
Four dimes, and then
Throw your name on the top of this too, the 100 grids. Throw your name on the top of that. Nice.
And she's got it right. My chocolate calculator.
Hey, that's 100, okay? So we have 10 over 10. Okay, so right now, it's only 47. 10 over 10 is what?
Yeah,
So we have 4 over 10 is 4. We're only taking 10 away. So once you take another 10 away,
Lightly shade and label.
okay.
0.4 over 4 cents.
Okay. So, hold on.
No, but D, it tells you to shade. Oh, A? No, it's just asking you. Just observe it. Make some observations. So, the whole year, we'll be working with perimeter and area. I'm trying to make you see perimeter here is 40, the area is 100. They're two totally different units. Right, so we have 40 units long versus 100 units squared. Because these are unit squares, right? Each one is 1 unit.
That's number 8.
Class, what's the perimeter? 40. What do you think actually, and what's the area? 100. Now, what's the difference between those numbers? If you just have 40 and you just have 100, your answers are wrong. If you just have 40 and you just have 100, your answers are wrong. Zach, what do you think? Ooh, so this units and units. Okay, so still. Units squared, because that's area. Each of these is a unit squared, because that is length. That does not deal with surface space. It deals with length. So length is just units. Area is units squared. So we already pretty much talked about that then. But in this problem, what could we say each square represents for this specific question? A penny, right? 1 cent. So then D asked you to shade in 40 pennies, or the 40 cents. E then asked us come on, let me clear it. There we go. The shade going the other direction. And what did we end up with? Alex?
4 cents.
4 cents that have been double shaded, right? So the 10% working horizontally and the 40 cents working vertically, the overlap is 4 cents, which means my shoelaces will cost, not that they'll cost 4 pennies, 36 cents. It's a tenth off. Were they really all wrong?
No, these three kept telling me it was 30, not 40, because it was 10 away, which is incorrect. Because
So make sure that you can explain out why, not just gloat that you were correct. So he'll save 4 cents. He'll spend 36. Now try that same strategy for what is 70% of 8/10, which is actually really easy. You just don't realize it yet.
Okay. I know I did do it. My class is coloring.
Sure.
We have to find 70% of 8/10.
So if you look at having 10 rows or 10 columns, you can easily show 8/10, right? Or 80%. Then if you flip the other direction, huh? For what?
Purple's Bay. I don't know what you're talking about, but Purple's Bay.
24 for which problem? I don't think how many are double shaded? Double
Good morning, Aubriana Craig, please come to the office. Aubriana Craig, please come to the office. Thank you.
Whoa, let's do that.
Thank you. You know why they say bless you? Your heart skips a beat?
Yeah.
Yep.
I'm gonna actually read it. Because people think that.
Yeah,
I know. Yeah. Is that your phone trying to say?
I've heard it wrong.
I've heard it.
Is that bad for your
I don't
heart?
know what I
Yes.
Sneezing is bad for your heart.
Arguably. Now, don't trust me, I'm not a doctor, but that's what I've been told. Alright, now, as I walked around, most of us, not all of us, most of us in one way, shape, or form shaded in 8. This would be a lot easier if I was using highlighter. I know, but I can't on this screen. So now, hold up. Give me your attention for just a second, because I got a question beyond the book. Now, if I ask you what 1 square represents, what does 1 square represent? 100th. No, and in this situation now, 100th of what? 100th of a kilogram, right? Because what we're talking about is 8/10 of a kilogram, which if we shade like this, each one has to be 100. So then we want to talk about, well, what's 70% of that? Or 70 out of 100. So we then shade 70 out of the 100. And the question becomes, which this looks really bad up here, how many are double shaded? Class, how many are double shaded? 56. That looks so nice. It's like Andy Warhol. Some
That's like
artwork right
James
there.
Bond stuff.
It's not as bad as mine.
Oh,
It's three shades. Yeah, three different colors.
So they become hysterical.
So, if we got 56, and we said each box was 100. So, the new shoes are going to weigh 0.56 kilograms, which means compared to the old shoes, what's the difference?
24 kilograms. I mean, 0.24.
Who was it that got 24? So that's where we get 24 for the difference. But it's 24 hundredths of a kilogram. Now, I don't know why they're working in kilograms, because that's a bigger unit. Well, I do know, actually. But rationalizing, like, we would not normally necessarily work in kilograms. We might instead work in grams. They're working in kilograms right now, so we have a number less than 1. Right? We're trying to deal with numbers less than 1, so we can look at it on a hundredths grid. Questions? Sweet. Moving on. So, we've talked a bunch this year about breaking up numbers. Right? Not like we're going to try to break them up because we're a mean girl, but we're going to break them up to make our life easier. I'm glad a couple people got my joke. So, quit abusing my tiles.
That was my boyfriend.
Your bag of tiles, inanimate object, we can talk later. Alright, so, now I will make true confession. I really don't like multiplication. Like by hand, I love multiplication calculators, right? That does my job for me. But we were never taught how to make our life easier. We were taught, here's the process, memorize it, do it. So, please trust me, because I had people fighting me with making generic rectangles on their homework and stuff. Please trust me with the generic rectangle, making your life easier. So just give me your eyes for a second while we work through this problem. Then you can do it on your notes. So, we want to multiply. What does this show? This generic rectangle, what is it representing? Boondir?
Representing the
It is not actually. Nina?
It's representing 1.4 times 2.3.
1.4 and 2.3. Now, it is kind of set up space-wise to help you visualize. 2 is bigger than 1. So that maybe that's what you were going for, Boondir, but that's not. We're not dealing with perimeter here, actually. We're actually going to deal with area. So sorry, that's why I steered away from you pretty quick, because we want to talk area. Nah, quit screwing with me. So now, if this is actually, if we think that's the dimensions of some object, the sum, sorry, not the sum, the product is your total area. Right? If we had a rectangle that was 5 by 3, the area is 15. That's easy. And that's the product. So here, what's the area of this space? What does class answer? 2. What's the area of this space? 0.8. It's 2 wide and 0.4 tall. What's the area of this space?
0.03.
Area of this space?
1.2.
1.2.
1.18. 7.17.
No, 1.2.
Think about it.
1.2.
Think about it.
I'm gonna be like high.
0.4 times 0.3, right? I would end up double shading that portion, right? What is that portion?
12. 1.2.
Now wait, you just said 1.2 or 12.
100.
Wouldn't 1.2 have to be 1.2?
Oh, so
It's 12 hundredths, which is 0.12. Now, here's the other thing. Here's the other thing if you draw your generic rectangles somewhat appropriately. If this space is only 0.3, how the heck would this be bigger? It doesn't make sense. So when we talk about making sense of the math, this area is obviously larger than this area. You should be able to correct yourself when you accidentally put the decimal in the wrong place. The other trick is, if there are two decimal places involved in multiplying, there will be two decimal places in my answer. One shape or another. Now, where that gets weird is where we have, like, this is a different problem, don't write this down, but if we had 0.4 times 0.5, and this is where people like to argue with me, the answer here is 0.20. There are two decimal places. This just doesn't matter. So people will argue, well, there's only one decimal place in that answer. No, we get 20 hundredths, and then that 0 just doesn't matter. So there's two decimal places to start, two decimal places in your answer.
One thing that's not, it's not exactly confusing, but for lack of a better word, confusing about this is I haven't method lattice multiplication.
Yeah, it's the same
Can I
sort of thing.
use that, would that be an acceptable thing to use? Or do I
Yeah,
have to
they're
use that?
relatively the same thing. I want you to understand,
Yeah, I understand how it works.
to answer your question, you would need to be able to do this if asked. So if on a test, I say, here's a generic rectangle, show how to find the product based off filling in the generic rectangle.
But for the homework, like if I did lattice.
You're fine.
Alright.
Yeah, so on just be able to do this, is what I'm saying. So then, to find the actual product, we now just add. So, take values that are similar to each other to make your life easier. 0.8, 0.3. Now, how many tenths do I get when I combine? 11 tenths, which is 1.1. So then 1.22. So we get a total 3.22 units squared, whatever the units are, it'll be units squared. Please make sure you have this written down, the generic rectangle drawn in your notes. I'll give you a second in case you don't. We need the generic rectangle shown too. So, Judy is working on part B. She sets up old school stacked multiplication. I mean, it really, so you guys know, old school doesn't, like, you can laugh at me. I literally, when I was a kid, my brother's 6 years older than me, and he and his friends would talk about, like, oh man, that's so old school. And I seriously thought they were talking about the school they used to attend. Like, old school meant like they're old. I'm not joking. I can't make this stuff up. Old school just means like the way we used to do things, right? So not your elementary school. That's not what I'm talking about. Old school is the way we used to do things. We, right? Society. Stacked multiplication. You line up your decimals, or you line up your end. You do it, right? You get 92 and 230. Now wait, hold on. Relate the old school stacked multiplication with the rectangle we just did. How are they related? And especially if I actually put my decimals in the right locations, Judy should actually have decimal there and decimal there. How do these relate? Alex?
Well, they both use the same number, and they get the same answer, but you're just using a different method to get.
Look at the top of the generic rectangle. 2 and 3/10. Look at the bottom part. 8/10, 12 hundredths, 92 hundredths. It's the same thing, just easier. So, on that, please do your homework. I will see you guys tomorrow. And it's Friday tomorrow, so yeah. Yeah, you can totally work ahead. You are welcome.